Welcome to week 5. This is our applied statistics class meeting. Before we begin our new type of graph, we're going to review a little bit about how to graph points. This is something you might have done in the past in a variety of classes, maybe algebra or geometry, or maybe this is the first time, and that's okay too. So we're going to learn how to graph points. So points are made from two numbers. We call them an ordered pair, and we write them as x comma y. To figure out what that means, we count from the origin. The origin is where the two axes cross. This point is 0, 0. So if we wanted to graph a different point, from that red dot 0, 0, we count right or left for the first value. Right is positive, left is negative. And then up or down for the second, the y value. So let's look at an example. Let's start by graphing point A, which will be at 4, 2. So again, I'm starting at the origin, and 4 means I count right 4. So 1, 2, 3, 4. The second number 2 means I count up 2, 1, 2. So my point A would be right there. Now for B, B is negative 5, 4. Negative means I count to the left. 1, 2, 3, 4, 5, and then 4, so up 4. So my point B is right there. You'll also notice the coordinate plane has names for the 4 different parts. Starting in quadrant 1, which is the most common, where both things are positive, and then working around counterclockwise. Now, the reason we're graphing points is to talk about a new kind of graph called scatter plots. And a scatter plot shows two sets of related data. So we graph the data as individual points, and sometimes we might connect those points and make a line graph. So shown here is an example of a scatter plot, and you'll notice it relates two things. It's looking for a relationship between shoe size and age. So we label those. Shoe size is the x-axis or the horizontal axis. Age is the y-axis or the vertical axis. And then what that means is we had lots of individual data. So this dot right here means that there was a child who had a size 4 shoe and his age was 8. This point in the top means that there was a child with a shoe size of 8 and his age was 13. Let's look at a couple questions from one of your first assignments. So if you're following along, please go ahead and open week 5 scatter plots assignments. Now on some of these questions, we started with points and then they actually connected them to see overall patterns of what was happening over time. So these are also line graphs. So in number 5, the graph shows the amount of gas in the tank of Sharon's car during a trip to her mom's house. What is graphed on the vertical axis? So across the bottom is the horizontal axis, and then up the side is what's called the vertical axis. And we can tell that this relates time and gallons. So we're looking at the vertical axis, so our answer is gallons of gas. In other questions, they'll ask a little bit more of this. So let's look overall at what's happening in this graph. So here's where she started driving. Over time, her gas went down as she was driving. I notice here it levels out. So nothing happened. She wasn't moving. But then when she starts moving again, notice suddenly I have more gas in the tank. So that means that she must have filled the gas back up. Then she's driving, her gas goes down. And then here her gas isn't changing. So probably she parked somewhere. That also makes sense because it's evening. We can also use scatter plots to make predictions. So number 9, Daniel is processing a large document on a computer. This scatter plot shows how many pages he has produced in 9 hours. Use the scatter plot to predict the number of pages Daniel can produce in 10 hours. So I can look at this and see there's a pattern. The more hours he works, the more pages he completes. And it looks like it's going up at a pretty steady rate. So I can just predict by kind of looking at it informally, or you might prefer to kind of draw a line on it to visualize it. So I just kind of free-handed a line that looked like it hit most of those dots. Then I'm trying to predict what he'll do in 10 hours. So I'm going to find 10 hours across the bottom and then go up to the line. Okay, I know it's going to be more than 40 because that's what he did in 9 hours. So it's going to be in the mid 40s, maybe 45. And this is an estimate. We are predicting what we think will happen. So as you saw in the last question, we can use scatter plots to predict future values. We can also look at it and determine if two things are related. So in the last example, it was pretty clear that how long you work is related to how many pages you complete. So we'll look for a meaningful correlation. And basically, we're looking for a pattern. Okay, what happens? So one type of pattern would mean as one increases, the other one does as well. Or maybe it's the opposite. As one value increases, the other one decreases. But that there is a pattern. We can see that things happen together. Or sometimes there's not a relationship. It might look like just a random set of dots. And that means there's no relationship. There's no pattern. Here are the mathematical names for those. So let's look first at positive correlation. Positive correlation means that both sets of data are increasing together. So if I were to draw a line, the line goes up higher to the right. Negative correlation, the line would go the other direction. So values of one set are increasing, but the other is decreasing. So notice if I draw a line, it goes down to the right. And finally, no correlation. The values might not be related. There might not be a pattern. Notice these dots are all kind of spread out. I can't really draw a line that shows an overall trend. Mathematically, we can look at this relationship with something called a correlation coefficient. And this is abbreviated with the letter R, lowercase r. And the R value shows both the direction and how strong the relationship is. So your R values will be between -1 to +1. Now, if it's +1, it would be an exact straight line that's increasing. So all the dots line up. If it's R equals -1, again, all the dots are on a straight line, but this time the line is decreasing. And if there's no pattern or relationship, our R is 0. Usually, we're going to have something in between those. So let's go back to the graphs we looked at the previous page. Remember, we said this first one was a positive correlation. So clearly there's a pattern, it's increasing, and it's fairly strong. Those numbers are all grouped together, but they're not all exactly on the line. I would estimate that this R value would probably be about 0.8. So the second one was our negative correlation. Again, those values are grouped pretty close to that line. I can clearly see there's a relationship, and it's a decreasing relationship. So my R value is going to be negative. That's what shows the direction. I think the strength is about the same. Those are all pretty grouped together. So I would say that the R equals negative 0.8. Okay, now let's look at the last one, no correlation. There's not really a pattern. So that's going to be pretty close to 0. It's kind of hard to estimate if I was going to say there was a pattern. Maybe, yeah, maybe a line like that. I don't know, but we're going to say that one's going to be really close to 0. Now let's look at your Cricket Chirps assignment. As you begin, you'll notice there's a lot of reading on the first page. Please take time to read through that. Okay, then we are using the same site that we used for the animal dot plot. It's important to notice one thing, that it tells us which graph to use, and important is that they want you to switch the variables on the X and Y axis. So we could graph things in two directions. We could put the chirps on the X axis and the temperature on the vertical, or we could switch them. And for this assignment, we want the temperature on the vertical axis, I'm sorry, the temperature on the horizontal axis and the chirps on the vertical. So in order to do this, you want to go over to the right where there's summary statistics and switch variables. So make sure before you begin this assignment that we have temperature on the bottom and chirps up the side for our Cricket Chirps temperature versus chirps. So now let's go ahead and let's actually look at that data. So remember, our goal is to look for a pattern. So number 1 asks, is this a pattern? And you can look at it and be like, well, yeah, obviously that line, which isn't shown at first, shows that there is an increasing relationship. So I would say, yeah, there clearly is a pattern. I can tell that as the temperature increases, the crickets chirp more. Number 2, is this a strong or a weak relationship? So again, informally, I can tell that by looking at the line. If your line isn't there, you can at the bottom click to show regression line under scatter plot controls. But informally, you can tell, yeah, those are pretty closely related. As one increases, so does the other. Later, you'll be asked to find an actual R value. This is not something you have to calculate on your own because it's a pretty detailed multi-step formula. But the great thing about technology is that we can find this in the summary statistics. So to the right of the graph, it shows the correlation. So this shows that our correlation is 0.991. So yeah, that's a very strong positive relationship. You can use this to answer the rest of the questions, and you're going to predict things about different temperatures and how many chirps you might expect. The last assignment I want to preview is analyze your own data project. First off, don't get concerned by the word project. It's actually a pretty doable project. Most students who complete this do really well on it. So let's look at what you're going to be doing in this project. The great thing about this project is that you get to pick what you're going to measure. So you're going to pick something to look at that you're going to be able to measure. So our data has to be numeric. So it might be something that we can do in length, time, weight, number of. The key thing is that this needs to be something that you can measure or record as a number, and you need to be able to get 20 or 30 of them. So there's a lot of examples. Some students did things like the number of pages in a book, the length of all the pencils in their house, the number of leaves on different flower stems. Okay, so these are going to be values that only have one number, so it's not a scatter plot. So you're going to decide on what you're going to measure, and you're going to get data again for 20 to 30 of those objects. We want it to be organized, so you're going to put it into a table, and you can do that using technology. So we're going to use either the website we were just looking at for Cricket Chirps, or we can also use Excel. And what we're going to do then using that technology is we're going to find the measure of center and measure of spread. So we're going to decide what we should measure. Should we measure median or mean? Should we measure standard deviation, IQR, range? We're going to make two graphs. One of those graphs has to be a box plot. And again, you're going to do this either on the Cricket Chirp site or using Excel. And then finally, you're going to write a summary explaining what this all means. Let's go ahead and let's look at another student's project so you have an idea of what the final thing will look like. Okay, so this student decided to record the length of songs in her playlist. Okay, so what she did then is she made a nice table organizing the data. Now, here she actually wrote down the song title and the artist. That might not apply. You might not have a specific information to put in the second column, and that's okay. Really, what we need is just this one column of data. So in this case, it's the length of a song. In your project, it might be number of leaves on a flower stem. It might be the length of my pencils, but you should have 20 to 30 numbers listed in one column. To calculate the different values, we're going to use either that Lock5Stat website or you can do Excel. Pick which one you're more comfortable in. You're going to type them into a list. Again, just one column of numbers. And in this case, I have the data that this student found. Remember, this is what it would look like on your chart. So this one isn't her data, but that's how she would have found it. So this student found in her data that the median was 3.19. Her IQR was 0.33. You need to do two graphs. Again, if you did them in the Lock5Stat website, you're noticing that you can flip between different graphs in this tab here at the top. One of them needs to be a box plot. Students often do box plot and histogram, but it's your choice. And then a key part is to write the summary. Okay, so some things that you're going to want to include in your summary is the student said that she found there were 3 outliers, but overall her data was fairly symmetric. She said she chose the median because she had 3 outliers in her data. And remember, outliers impact your mean. So she told me the median and the IQR, and then did a little reflection. She wasn't very surprised by the data because songs are usually about 3 minutes. She thought it was difficult at first because she had some issues in the graph and she figured out why it was happening. Okay, so the summary is telling me those different data points and what they mean, and a little bit about your process. Again, this is an assignment that most students do really well on. Start it here in week 5, but if you can't finish it right away in week 5, that's fine. Just make sure you don't forget about it. This is worth more points than your regular assignments. If you have questions on it, make sure you reach out, drop by, and we can get something set up together. Thanks for previewing week 5 with me. I hope you guys have a wonderful week. Have a great day. Bye.